For my project, I decided to present my findings from my ISEF research that looked at the effect of magnets and electromagnetic radiation on European honeybee or Apis mellifera navigation. And so basically, I decided to look at this because bees are really integral facets of both agriculture and apiaries, and they're important pollinators. And researchers have already found that radio waves have an adverse effect on bees' abilities on queen bee development, as well as they've found ferromagnetic material in bees' abdomens. So with these two things in mind, what I decided to do was look at the effects in terms of navigation that these two things would have, because few studies had looked in depth at the effect that close proximity radio wave exposure had on European honeybee navigation. And so this brought me to this question of how do radio waves and iron magnets affect Apis mellifera navigation through a straight PVC track? And so what I hypothesized was that exposure to iron magnets was going to negatively impact their ability to navigate through a straight PVC track as measured in the time it took for them to reach a sugar and honey cache at the end of this. And the reason I ran this iron magnet trial was just to corroborate those findings from other studies that had already looked at the effect of iron magnets and had already found ferromagnetic material in bees' abdomens. So this was really just building off of that as a stepping stone to look forward and then build to my final and really the key part of my research was looking at the effect that radio waves had on bees' abilities to navigate. And I predicted that since, well, all a radio wave is just a parallel electric or a perpendicular electric and magnetic field. Well, I predicted that since there's a magnetic field there, what's going to happen is that the ferromagnetic material in the bees' abdomens are just going to be polarized, and you're going to get that similar effect to an iron magnet, which is going to disorient the bee and make it so that it takes them longer to navigate through the straight PVC track. And so with that in mind, I started optimizing a track. It initially started out quite long, but then over time I settled on a shorter version of the track. And so in my methods, what I did is I only used female foraging honeybees because males don't forage, and so that would have skewed my data in a direction that I didn't want. And in addition, I used 2.4 kilo Oersted iron magnets, and those were placed on opposite sides of the PVC track, just about right in the middle. And then I ran another trial with cell phones, where cell phones were attached to the outside of this PVC track. And then all the time, what happened was there was white paper around the outside of the track, so bees had a constant field of vision. And then I used a sample size of n equals 40 for each trial because I wanted to have the most accurate data possible. And then in addition to all this, the track was washed after each trial in order to minimize the effect of pheromones. And so I was talking earlier about this longer track and how I settled on a shorter version of this track. And the reason for that was because what I really wanted to do was expand my data size as much as possible. And so by shortening my track, I was able to expand my sample size, and so I collected 120 data points in total. Data points for the control, for the iron magnet trial, and then finally for the radio wave trial. And so here you can see is the final track that I landed on, and there's a bee sitting right there in the holding container. And this holding container, bees were put in there, and then they would be herded through they would be herded into the entrance of the track. The entrance would be closed, and the time it took them to reach the sugar and honey cache at the end would be timed and recorded. Okay, so what did I find? Basically what I found was that in between the control and the iron magnet trials, there was a significant difference. In other words, it took bees significantly longer to travel through the maze when exposed to iron magnets. And this held true with cell phones as well, where cell phones, it took significantly longer for bees to travel through this track when exposed to cell phones versus when exposed to the control, or versus, as well as when they were versus cell phones versus the iron magnet trial. And so basically this corroborated my findings because I figured both iron magnets and cell phones would have an impact on bees' ability to navigate, but I was really surprised at just how significant that impact was. And it was also noticeable too because I could look through the end of the track and see what bees were doing, and they were noticeably more agitated during the iron magnet trials and during the cell phone trials, as they would go back and forth and walk in circles more, whereas during the control trial, they'd all walked in a pretty straight shot to the sugar and honey cache at the end of the track. And so after this, the results that I got were that iron magnets took bees 68.36 seconds for bees to reach the end of the track. Cell phones were 155.22 seconds on average for bees to reach the end of the track. And then the control, it took them about 15.85 seconds on average to reach the end of the track. So that's pretty significant in terms of the effect that close proximity radio wave exposure is having on bees' abilities to navigate. And there you can see a bee in the track during an actual trial, and then that sugar and honey cache at the end. And so my results do corroborate my hypothesis, but they kind of brought about this question for me, which was, why did the radio wave make it take longer for the bee to reach that honey cache at the end than during the iron magnet trial? And so I think this is something to do with the relative intensities of the radio waves propagating from the two cell phones versus the 2.4 kilo Oersted magnet. But unfortunately, I didn't have the technology to be able to measure those two facets, and they're relatively unimportant because what's important is just how they compare to the control trial. And then this leads to the final kind of key idea here. And what are the implications of this? Which possibly none. It's not like you're shoving your cell phone up to a bee on a regular basis, but what they do illustrate is that close proximity radio wave exposure negatively impacts Apis mellifera's ability to orient and navigate, which raises concerns about 5G networks in the future, which are going to increase the density of the distribution of radio wave and cell phone antenna around given areas. And so what does this lead to? What future research can I do? And really there's a huge array of different options. You could look at bee learning, the effect that 5G specific frequencies have. I only looked at 4G frequencies. You could have more control over the frequencies you use with RF generators. And then looking at the effect of distance, the distance that these radio waves are from the bees and the PDC track, because that's really what's crucial. If it's only 4 centimeters or 5 centimeters from a bee that this radio wave exposure has an impact, well then it's not really that important in the whole scheme of things. And then maybe looking at longer, more complex tracks and bees' abilities to learn these and the effects that radio waves have on bee learning. And so thanks so much for watching. This was my chem presentation. Thank you.